Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Last week, before our experiment got cut off, we were talking about some of the things that we liked about Kotlin, and since then I've made a list of things that because we were trying to remember stuff off the top of our head. We're doing a pretty good job, but so now we have a list and we can pick and choose from these things.
Nice.
Because I think like one of the things that we maybe didn't emphasize that much was the syntax simplicity and clarity, and how there's a lot less code. And, you know, it's interesting because people have different opinions about code volume. And some people go, well, the IDE will write this code for you, so it's okay. But my feeling...
Or just make the language better so you don't need all that code.
And also, I feel like it's not really about that. It's about like when somebody else is reading the code. Code is read much more than it is written.
Yeah.
So... and I'm hyper aware of that because the code that I'm writing goes into books, and I want people to be able to look at it and get the idea without struggling.
Yeah, I think that's the goal of modern languages, is to allow you to most simply convey what you're trying to do. Whereas programming languages of the past, the code doesn't express very clearly what you're trying to do generally. And so yeah, I think the expressiveness of Kotlin is something where the code is a lot more directly related to the actual goal.
Well, I would say expressiveness and, you know, sensibility to the reader, but also safety. I think that's the other thing that this is what we're trying to achieve with functional programming and the null stuff in Kotlin and, you know, all of that stuff.
Yeah.
But there are things that it releases you from the tyranny of the Java designers, like top level functions and not having to put one class per file.
Yeah.
I mean, what a kind of arbitrary, painful decision. Not even.
There's definitely a lot of things that you do for the compiler in Java.
Yes, there are. Yeah, the type inference.
Yeah.
The inability to do a lot of the type inference that you can do in Kotlin, and then. Well, named and default arguments. I know we didn't talk about that. I think, awesome. Well, I don't know. The first place that I was exposed to that was in Python. So it's very possible that they picked it up from Python. But that saves a lot of, you know, bunch of special cases, and it's much more readable. You can see what it's doing.
I've been on just this warpath against builder pattern lately.
Yeah. So talk about that, because I'm not really sure. And Kotlin does have some pretty strong support for or at least a variant of the builder pattern, which maybe won't offend you as much. But what aspect of it is?
I just have run into so many issues where I didn't provide the builder the things in the right order, or I forgot something that was required, because the constructs of a builder don't convey to you, the builder pattern don't convey to you ordering or required things. And so it ends up resulting in just weird behavior that then you have to debug into the builder and see, oh, I was supposed to set this thing before I did this thing because it needed it. And all that stuff is not conveyed when you use builder pattern. Whereas constructors with default parameters provide you a lot of the, and specifically immutable builders, where the mutable builder, the mutability of the builder pattern is what's causing all these issues. Whereas if you can just construct objects, immutable objects from constructors, then you don't have to worry about the challenges that arise from the mutability underneath the builder.
Well, but I think a lot of the goal of the builder pattern is to have put the flexibility inside of the Lambda is so that you can do, I mean, like the string builder, I mean, there's no particular way that you want to build a string.
Right.
You're just piecing it together in the way that you want to, and then it produces this immutable string at the end.
Yeah.
And it's I think a lot cleaner than having a piece of code where you're hammering together a string.
Yeah.
So, maybe it's a usage issue.
I think that what it points out to me is languages that don't have flexibility in constructing immutable objects, and that creates the need for mutable builders, and then just things like optional, like being able to express optionality in the type system, which Kotlin can do. And so I guess I don't know in Kotlin. I guess you can set using the question mark, you can in a constructor parameter say that the default value is null or something. Right?
Nullable.
Yeah.
Right. Yeah, and then you can say it is nullable and
the default is null.
Or let's see. I think you have to provide the type in the argument.
Yeah. Yeah.
You can't just use type inference to decide.
Yeah.
Well, and I did check with Svetlana about the mapping of optional to null with the Elvis and the question dot. And she said, yes, they satisfy the same intent, but with Kotlin, it's checked at compile time and it's built into the language, and you don't have the overhead of the optional object.
Yep.
So it is there, and I'm still getting my head around that, like going, are we getting the same effect? But in general, it does seem like it's getting the same effect. And I think as long as it's preventing the null pointer exception, I guess it's okay.
Yeah.
It's doing the job, and it's doing it better than optional is. So, so that's a plus. I don't think, did we talk about no checked exceptions before?
I don't remember.
That's pretty big, I think, not being forced to handle the checked exceptions.
Yeah.
Everywhere.
Yeah.
That's inappropriate most of the time.
Yeah.
Yeah.
God, checked exceptions. I haven't had to deal with them in a long time. But what's funny is that my programming style now for error handling is kind of like checked exceptions, but putting them into the type system, like putting them into a return value. So it's in.
Yeah, I mean, I see what you're saying, but I don't know if I would say it kind of like, I mean, I guess
it's not.
I recoil against anything that says kind of like checked exceptions.
But what's interesting is that it puts it in the hands of the caller,
right,
to have to deal with,
which is what this null/optional approach does with in Kotlin.
Yeah.
So I
guess that's been a general movement with language design, is to it kind of swinging the pendulum back to putting it in the responsibility of the caller to deal with. Yeah.
Yeah. I think what we discovered with the Java checked exception experiment, which I think somebody may have said that it was reproduced in like one other language somewhere. But as far as, I think effectively nobody has repeated that mistake.
Hopefully in a few years down the road, we can say that about just exceptions in general, that exceptions were a mistake.
Yeah. Yeah. Well, or that there are things that you only use. I mean, it's almost like the way Go had the
panic.
It's a panic. Now they're talking about adding a few, more things, but I think if we think of it in terms of isolating it to some special cases, I think because there's certain situations where you go, I have no idea what to do here.
Well, it's like out of memory. Like, why is that an exception? Just crash the process.
Just
like, because you can't recover from an out of memory exception.
Well, I guess the only thing that you could hope to do in that case is say that
maybe some cleanup.
Well, no, I don't think you can recover from it. I mean, I think maybe that's the thing. Exceptions, the way I describe them, is their goal is recovery.
Right.
So if you can't recover,
like Stack Overflow, like you're done, right?
But you might be able to report. You might be able to capture some information about why that happened and report it as an error so that, it could be debugged. But if it's like, well, I called out, I tried to do some IO, nothing came back, or, it told me no, or something like that. It's like, well,
computer says no.
The computer says no. And there's kind of a very high level way to recover from that, which is to say, well, I guess you can try again for a while. And but even that, should that even be an exception? Because you're doing something on the network and you expect that uncertainty.
Right.
So,
or even on the file system.
The file system could fail.
Yeah. And so it puts the onus on the caller to have to determine what is my recovery or my failure path here.
Yeah. So I think Go's approach might be, a better way of thinking about it, saying, there's a few cases here where you don't know what to do, and throwing up your hands and going, somebody else has got to deal with this at a higher level. That's one thing. But when you're making a function call, you shouldn't have this very circuitous thing that comes around and says, oh, I've thrown an exception, you have to catch it. And you go, oh, I called this function and it didn't give me the expect. Yeah, that's probably not the right model for that. Yeah. Maybe the real problem, I suspect, was that they said, we have the one solution, and it wasn't.
Right. Yeah. Well, and what's nice about exceptions, not unchecked exceptions in particular, is that you can ignore them. Whereas when you get into the type of programming that I'm doing now, where the possible errors are put into a monad return type, you really can't ignore, or it feels really dirty to ignore the possibility that something went wrong. Whereas in unchecked exceptions, you can write a lot of code and just assume that you're always going to be on the happy path, and that makes the code more concise, more, if you just want to assume the happy path, then your code can be pretty clean.
That was my initial assumption when I first encountered this years and years ago at the University of Washington, when we were doing, research into C++ and libraries and things like that. As I always just said, wow, nothing will go wrong. And I think of that and I go, I bet a lot of computer science graduates have that attitude, is that, no, I'm protected. A lot of people, I think, using Java will say, well, the compiler has my back. And no, it doesn't.
Yeah.
We just don't. Yeah, I think initially we didn't really think that much about errors, and it's just been a slow process of kind of getting more and more attuned to the idea that bad stuff is going to happen, and you got to be.
Yeah, I mean, shouldn't we really be encouraging all developers to think about the possible error paths and how they want to deal with those, rather than the unchecked exception method, which is just, you can ignore it? Because I think ultimately that creates such bad quality of code, is the mentality that you can ignore it, and then all of a sudden something goes wrong and you ignored it, and then things don't work as expected, which I think just creates, I run into so many bugs in every piece of software that I interact with every day, and it drives me crazy. And I think that a lot of it is just that we haven't taught people the right practices for how to deal with possible errors. And our programming languages haven't steered people in the right direction of, you really should think about the fact that this can fail and what you want to do in that case.
Yeah, it's
a cultural problem, right?
It's a cultural problem, but also I think it comes from our educational institutions, which, maybe it sidled over from math, and with math you can create, proofs and make sure everything is correct. And there were attempts for a while to figure out a programming language that could be proved correct, where you could have a provably correct program. And there's probably people still working on that. But
there's a few languages that are still exploring that. But I think I've gotten really close to that with functional programming, in at least the way that I do it, is that when I call a function, I am pretty close to guaranteed that what I'm going to get out of that function is what the type system tells me are the options. Whereas if you call a function in Java, you could get the thing that you expect, you could get an exception, or you could get null, right? And so, like, thank goodness Kotlin at least takes one of those things out of the equation, so that you can expect that you only get null if you've told it that it's possibly nullable. But exceptions are still there and used in Kotlin. So you still have the exception route. Whereas for me, my type signature expresses exactly what my potential outputs of calling any given function are.
Mm-hmm. Yeah. Well, I mean, there's things in university programs that are not taught. And I think, the fact that stuff can go wrong is not, there should be at least one class in what happens when things go wrong.
Yeah.
And that things will go wrong, but I don't think there are. I was just speaking to one of the programmers in the startup, the TribeWorks consulting firm that we started up, and they're fresh out of school. And, a year and 2 years out of school. So, but one of them was saying, so what's this thing about namespaces? I'm not clear about namespaces. And it's always, it's not, I don't hold that against them at all, because it's the kind of thing that, they didn't teach you this in school. And there's a lot of things like that, which are really pretty fundamental concepts that they should have at their fingertips.
I think in general, schools teach mostly happy path programming.
Yes, I think so.
And so I think you're right to identify that there's a cultural problem, but connected to that cultural problem is the educational methods. But
and
happy path programming,
possibly coming from the math world, where you prove it and then you can just move on and not think about you don't think about calling a function and having it fail
in math.
No. The function always works. And so but and I suppose maybe it seems a little disheartening if you go, okay, so you're going to write this program and you say hello world, now let's talk about how that might fail. It's like, what? It's maybe a little overwhelming at first. And so it's like, well, let's just go along the happy path.
Yeah.
And then maybe we never get around to some of these really important details, like how to use GitHub.
Yeah.
Well, distributed version control, I think, would be an extremely useful thing to be teaching in school. Yeah. And eventually they will.
Yeah.
If universities still exist, and you don't just get it off of YouTube.
It's funny you mentioned the Hello World example, because in the functional programming that I've been doing lately, Hello World actually can fail, and you have to think about the ways that Hello World could fail. So interestingly, when you call system.out.println in Java, Kotlin, on the JVM, whatever, that can throw an IO exception, because if it can't actually write to standard out. And I think that there's
Like maybe you're on a machine and there's no console or something.
Exactly.
Okay.
Right.
Okay.
And so what's interesting in the Scala Zia stuff that I've been doing, when you want to print out to the console, the return type of that actually includes the possibility that it could have produced an IO exception while trying to write to the console. So it's, but it is really weird to think that Hello World could fail and what you do about that. But how different would that be for people as they're learning programming to be taught to think about the possible error conditions?
But even I can do, if like I that. Do hello, I can write Hello World on this device, and it has,
that's a native fruit.
That's a native fruit, and, you can run Python on it really easily, and I can write Hello World to it. And where's that going? I don't know. It doesn't get to the console.
Yeah.
So,
yeah. Huh. So Kotlin, there's a ton of syntax things. I think you've said before that Kotlin has taken a lot of experiments from other languages and taken the things that have kind of improved to be good improvements and pull them into the language.
Real successes.
Like string templates are just like so obvious, and it's so great that Kotlin has this.
And that they get to, like, because Python has been mutating its string output for decades. Somebody comes up with a better version and everybody goes, oh my gosh, that's so much better, we have to put that in the language. But then you still have all the others there. But we're now able to see the Kotlin's able to use something that after all of that evolution has happened. So and it's really basic, and it's been quite bothersome in the past. And so now things like that are.
There's a ton of things like that, like ranges you have on your list, data classes, of course, like no new. The expressionality of if is nice.
The fact that it's an expression rather than a statement. So you get a return value from it, so you don't have to have a ternary expression.
But I don't think they took it far enough with Kotlin. I mean, maybe they have to cater to Java developers being more statement oriented. But I now, having used Scala, where everything is an expression, I can't go back to language. I guess I do write a lot of Kotlin, so I can't go back to it, but it feels. But
you notice it because you're going, oh wait, is this a statement? Or an expression? Because once you get used to the idea of, well, it's going to produce something. It does. I mean, if I was designing a language from scratch, I would say definitely everything is an expression.
So I think it is having if as an expression is awesome. And I use that all the time in Kotlin.
Right. And it does, I mean, the parsing the ternary operator is never, it's like something I have to stop and think about. Whereas the if expression, even though it's longer than the ternary operator, it's easier to read.
You can do it in Kotlin all on a single line.
You can. You can write an if statement. You don't have to have the braces, which
there's just no reason for the ternary operator.
No. So they don't have it.
They don't.
No. There's no ternary operator in Kotlin because you're supposed to use the if expression. Right. Yeah.
Nice.
I have. I mean, I go back and forth with Svetlana, my co-author, about. There's a lot of these things that don't require curly braces. And so my thing is, well, if I have a one line, if it's an if or something like that, and I have a one line, then, well, I tend not to put them in for a single line. That's I go back.
The Python developer.
It's partly it's that. It's partly it's just, well, if you don't require me to have curly braces, I'm not going to put them in.
So the one place where I found where I put them in even when they're not needed is because sometimes when I'm writing code and debugging, in one of my blocks, I want to like throw a println in, and then all of a sudden I have to switch to the
curly
braces, and it just gets too awkward. So a lot of times I just put them in because I might have to like do a println.
No, I guess what I would have liked is them to have made it a language requirement. But the one place where that would be detrimental is that one line,
the one-liner
if statement.
Yeah.
But still, I would have, so that's part of my stubbornness about that, is going, well, you should have made it a requirement, rather than saying it's optional.
That is one really nice thing about Kotlin, is that there are generally very few ways to do the same thing, whereas in Scala there's like 100 ways to do the same thing for every given thing, and it makes the language a lot harder to learn, because you'll look at a piece of code and be like, that's not the way that I learned how to do this, so I don't understand.
Yep,
so there's
that was
a lot
my
of cognitive
experience.
overhead. Whereas thankfully, I think Kotlin did a good job of generally providing very few ways to do the same thing.
Oh yeah. I think that was definitely one of their goals.
Yeah.
So,
we were talking about server-side Kotlin stuff,
yes,
a little bit in the section that got cut off
before we got cut off.
Yeah. So we should probably come back to that. And it's something that I've been doing a lot of, is server-side Kotlin, and using all the different options for that.
For frameworks.
Yeah. So
what have you tried?
So the one that I've done the most with is actually gRPC Kotlin, because I'm on the team that's been working on that, and that's cool and interesting, and takes care of a lot of the serialization.
You're on the gRPC team?
The gRPC Kotlin team.
gRPC Kotlin team. Okay, cool.
Yeah. So that's cool, and takes care of a lot of the serialization stuff that you normally have to be more explicit about. So I think it's a great option.
And it's super efficient, right?
Yeah, it uses like HTTP2 and protobufs and stuff. So, but I've been doing traditional server-side development for so long. I've done more work with, or I've used the traditional frameworks more, and then some of the modern kind of traditional style frameworks. So Spring Boot now has great Kotlin support, and I've used that in a number of places. And then there's a newer framework called Micronaut, which has great support for Kotlin. And then Quarkus has okay support for Kotlin. They don't support like coroutines yet, which is a bummer, at least last I saw.
And Micronaut does? Or
Micronaut does, yeah. And Spring Boot
Kotlin
does.
coroutines?
Yeah.
Oh.
Yeah, all built on reactive IO stuff. So it's great. And then I've used Ktor, which is the JetBrains HTTP, both client and server library.
How's that?
It's good. It's definitely more Kotlin idiomatic, because it's only Kotlin, whereas the other ones support Java and Kotlin, and Micronaut supports Groovy as well. Maybe Spring supports Groovy. I don't know. But so Ktor is nice because they use more of the Kotlinisms for constructing an application and stuff. So there's a lot of benefits to all of them. I think the one that I have enjoyed using the most is actually Micronaut.
Really?
Yeah. The way that they do their dependency injection and some of that stuff, just it's nice and clean. And there's this cool thing where you can say, you can through annotations kind of build your tree of injection, of dependency injection. So it makes it easy to do things where you want to switch between one provider and another provider given like your environment. So in my case, I'm running on Google Cloud for production, but then locally I'm not, running on Google Cloud. So I have a different provider for like my database or whatever it may be, or maybe it's my database configuration or whatever. And so Micronaut makes it super easy to like say, okay, if my environment is Google Cloud, use this, inject this thing. And if it's running locally, inject this thing. And so the like wiring of the tree of dependencies with Micronaut I found to be really nice.
So how do you, you're looking at all these different frameworks, and I'm asking this because we're creating kind of a prototype using Django on the back end, which is, and they've done a lot of work to, for performance and things like that on Django. So, but how do you like evaluate one framework against another? Like there's so many variables, it seems like.
Yeah. And as usual, the answer is it depends on what you're doing. And a lot of the applications I build are kind of full stack applications. They're not just a REST API. So it would probably be a different answer if you're just doing kind of a backend service versus a full stack application. Luckily, I'm in my job able to explore lots of different things and try lots of different things.
It kind of is your job.
It kind of is my job. So I have the ability to do all that experimentation, whereas obviously not everyone has that. So, it depends. If you're a Spring developer, like you've been doing Java Spring, then obviously like Spring Boot with Kotlin is an easy step forward. Whereas if you're kind of coming into Kotlin new to server-side programming, maybe you've been doing Android programming, then maybe like Ktor is going to be a great choice. If you're building just purely like backend service stuff, then maybe gRPC would be a good choice. And so yeah, I think it does depend on kind of your background and what you're using it for and all that. But
so no easy choice.
We related to this last time we were talking about Kotlin native,
right?
And I was saying that GraalVM I think has taken away some of the need for Kotlin native. And you asked, what is GraalVM? So let's talk about GraalVM.
Yeah.
So GraalVM is a new VM from Oracle that has a mode that allows ahead of time compilation of a JVM application into a native executable.
Mm-hmm.
And so what it does is it'll take your jar files of your application and then turn those into ahead of time compile them into a native executable. And so this, I think, accomplishes a lot of the same things as Kotlin native, where it's optimized for a specific system. It does the ahead of time compilation, so it starts up faster. It uses less memory, all those kinds of things. And so I haven't been as interested in Kotlin native and exploring that, because with Kotlin native, you have to toss out a lot of the JVM stuff that I'm used to programming against. Whereas with
you mean the libraries and things?
The libraries, yeah.
Okay.
Yeah.
Yeah. Why is that, do you think?
Why do you have to
toss out some of that stuff?
Because if you want to use like Java collections, you have to be on the JVM.
Okay. So whereas GraalVM just brings it all in, it sounds like that would make a pretty, not that that's as important anymore, but a pretty big executable.
It's surprisingly small.
Really?
Yeah, because it actually figures out the execution paths, and so it's optimized. It's not taking every single piece of bytecode that's in every jar file that you have linked against and putting that all into the executable. It doesn't do that, as far as I can tell. It actually like analyzes what the execution paths are, and then based on those execution paths creates the native image, the native executable. So yeah, they're not as small as I think other languages like Go can produce some generally pretty small.
Yeah, but it's a pretty amazing compromise. So do you suppose that's coming from like one of the versions of Java, they had the breaking up of the, I forget
the module
modularization.
System.
Yeah, the module system. Is that
no?
why?
I think it's different from my understanding, which could be totally wrong, and hopefully people correct me. But my understanding is that it actually analyzes the execution path of the program and only ahead of time compiles into the native executable those things. And so even if you have stuff in your module path or your class path or whatever, if they don't get used, they don't go into that native executable.
So it didn't need the module system in order for,
as far as I know.
That's a pretty...
and there's GraalVM for Java 8, which is before the module system.
Oh, yeah, that's true. Yeah, so okay. That's a pretty... Who's behind that? Is that another Brian Getz genius
I'm sure
piece?
that Brian is involved, but there is a very large team at Oracle that is working on this right now. Wow. So they've invested a ton into it, and it's engineering feats that are remarkable for sure.
They are. Now, I mean, pardon me, I've come not to trust Oracle very much. Is this something that they're going to pull the carpet out from under us?
There has been some concerns about the licensing of GraalVM. They do have a commercial license that you can buy, which I think unlocks like performance enhancements and stuff. So I think they do have a model to make money off of this, which is good.
Yeah, I don't mind that. It's just that, sometimes historically
some people have been concerned about the license of GraalVM, but I haven't looked into it. So one of the really interesting uses for GraalVM is for server-side stuff. There's serverless, which the big thing that serverless gives you is the ability to match the demand on your service, your application, with what you actually pay for. And the only real way to do that is to turn things off when they're not being used. And so then you have to spin things up when demand comes in. That's the whole like serverless model is all on demand provided, but not keeping stuff running when it's not needed. So the downside to that model, that operational model, is that if something takes a long time to start up, then your potentially your users are just sitting there waiting. It's a weird experience if you like add something to your shopping cart and it doesn't seem to respond. And so this is called a cold start, and cold starts are a lot bigger problem on the JVM than they are with Python and Node and Go and those sorts of things. Just because the usual spin up time to start the VM, you
got to warm it up. You got to check the oil and wash the windows.
Right. I mean, the whole JVM was optimized around long running applications that would JIT over time and get faster and faster and faster. Right. And in the serverless model, that just doesn't fit very well. And so GraalVM with serverless has actually been something that's catching on, where then you get the ahead of time compilation, you get the fast startup, you get lower memory usage. And so that's a big part of what I've been exploring, is how to do GraalVM for serverless for JVM based applications.
So do you think that was their initial target? It was for serverless stuff to speed that up?
I feel like they got started before serverless was a thing, but maybe not. Maybe so. AWS Lambda was one of the first kind of serverless environments, and maybe that's what ultimately kind of sparked the idea for GraalVM. I'm not totally sure, but or maybe it was what's it called, simultaneous invention or something, where just people realized that there were use cases where,
like calculus,
right?
Yeah, Newton and Leibniz getting the idea at the same time.
Light bulbs too, right?
Yeah, right. Yeah.
So I don't know all the history of GraalVM, but it's been interesting, and I have played with it with Kotlin and had pretty good results. One of the challenges of GraalVM is that when you use reflection, you have to tell the ahead of time compiler about where you're using reflection, because obviously, like if it's analyzing all the execution paths, as soon as you use reflection, it can no longer...
all bets are off.
Yeah, exactly. And so you have to tell GraalVM about where you're using reflection. And in traditional Java applications, it can be really hard to figure out all the places where you use reflection, because it gets used in so many places. And so some of the frameworks do a really good job of helping you address that particular issue, and using...
So like Micronaut doesn't use reflection, I think.
And specifically to work well with GraalVM. And I think there's probably even outside of GraalVM, there's some other benefits to doing that as well. But I think that they actually use the Kotlin annotation processor as their way of doing annotation processing without reflection, whereas Spring Boot uses reflection for its annotation stuff.
So have you used GraalVM to just create like standalone command line apps?
I tried, and I ran into challenges with that. There is a tool that is well set up to do this called Pico CLI, and it has a GraalVM like mode. And so people are doing this, and I think that it's interesting. One of the downsides is that the executables do tend to be larger than if you'd create them with C or C++ or even Go or Rust.
But these days, it's not as big of an issue.
Yeah. And then GraalVM's targeting different platforms is kind of painful today. So if you want to create a Windows executable, a Linux executable, and a Mac executable with GraalVM, it's a little painful. And so I think people are doing this, but it's not something that has gotten broad adoption yet.
Yeah, the cross-platform thing has always just been a headache.
Always. Yeah, so server-side Kotlin, I've been enjoying it, and there's a lot of great things out there for doing it. It's definitely catching on a lot more, and so with like coroutines, it just fits so well with the server-side programming model. So, yeah. So yeah, the server-side stuff. What else do we like about Kotlin or not like about Kotlin?
Let's see what. Well, so now I'm checking with Svetlana about this, but Bill just explained to me about, I think this is in Scala 3, and it's called type unions.
Okay. ADTs, algebraic data types.
Well, this was basically what it does is it allows you to say, the way I categorized it was as a constrained any. So instead of just saying any and then inside having, a when and matching against all the types and then having a default.
Yeah.
What a type union would do if it existed in Kotlin is it would say, okay, I'm going to have, it could be a dog or a robot or a person.
Yeah.
Those are the only 3 types you can pass, but it could be, and they're all disjointed. They're not part of the same hierarchy. And then inside your when, you would say, okay, if it's a dog, if it's a person, it's a robot.
Yeah.
And you don't have to have a default.
Yeah.
And then it constrains how you use it. When you call it, the compiler will say only this. And once I understood it, I said, oh, that sounds like a feature that Kotlin would want to have. I mean, it's straightforward.
So this is algebraic data types. ADTs.
Oh, that's what they call. Well, that's,
and there's as far as I know, two different types of algebraic data types. There's product types and sum types. And I always get them. It's so hard to remember the terminology and which one is which, but I think, just going off of the top of my head, product type is like a data class or a case class in Scala, where it's using the and operator, product with and. And so if you want to construct a class that has a string and an int and whatever, right? That's like an and operation. The data class matches that construct well. And then there's the sum type, which is what you were just describing, where you want to use the logical or in type construction. So a dog or a bird or whatever. And where ADTs really shine is in pattern matching. And so it was nice that you pointed out that, because that's where the usage of ADTs is just awesome, because then you can pattern match on the sum types, and it just is really clean, and you don't have to have the typical way to do sum types is with in Scala it's a sealed trait. Kotlin has something similar for
it has sealed today. Classes.
Yeah, and where you say these are the possible types that are that type or express that particular type, and then you can pattern match on those. And I think that Kotlin's pattern matching will tell you when you haven't done an exhaustive pattern match.
Oh yes.
Okay, so that is that is a way to do sum types. It just is more overhead because you have to create that sealed class, whereas with like true ADTs, you can just ad hoc chain together classes with like an or operator.
Right. Well, because the sealed class is like a single hierarchy.
That's right.
Whereas what we're talking about with these type unions is completely disjoint types that you can say, here are the different things that this function can work on.
Yeah.
And they can have nothing at all in common.
Yeah.
But it constrains.
But you could create that with a sealed class too. It just is more.
It overhead. Requires a sealed class has to have subclasses.
Yeah.
That so they're in that. I mean, I guess I see what you mean, but it's much more awkward and less.
Yes. Well, it's not, and it's not ad hoc. Like
that's right. That's right.
The sum types in Scala 3, you don't have to create that kind of wrapper class around it. You can just say dog or bird or whatever,
right.
and it will. I'm guessing underneath the covers, it creates the sealed trait that all then inherit from or something. I don't know.
Does it.
It creates a common class.
Some way. Yeah. I mean, but we don't need to look at that.
Exactly.
We just go, okay, here are the possible types that I can accept with my quote unquote any. And then in my when expression or my pattern match, I know I've got them all. And I also know, whereas an unconstrained any, it's just like, well, you could call that.
Well, you always have to have the default match.
You have to have the default match, and the compiler isn't going to check to see whether you're passing it the right thing. It's just going, well, any, that means any.
Yeah.
And so it's runtime, whereas this does it at compile time.
Yeah. So ADTs are awesome, and it's too bad that Kotlin doesn't yet have the like real syntax for some types.
Yeah, but I could totally see them putting that in. Yeah. That's the kind of thing, and that's why I'm asking. I haven't heard back about it, but it seems like that would be a good thing.
Yeah. But the pattern matching in Kotlin is good. It's not quite as powerful as Scala's, but it's
also simpler to understand.
Yeah.
I think the pattern matching that's going to go into Python 3.10 is more closer to Scala's.
Yeah.
It's it may be just picking up everything from Scala, so it will have more power and possibly complexity as well.
Yep. Yeah. Coroutines. We should talk about coroutines. I think that was in our section that got cut off last time.
Okay. Yeah.
I like coroutines, but I do find that after having done more functional programming stuff, concurrent programming, async programming with Scala, that coroutines are a little lacking to me in like error handling. Like it's still using exceptions, and the code gets messy when you have to think about the possible ways that a coroutine can fail and that kind of stuff.
I feel like I've read something to the effect that that's a significant area of interest, and maybe even in 1.4 there's been some improvements in dealing with errors in coroutines. So hopefully it gets better, but coroutines definitely make async programming a lot more accessible to Java developers, whereas if you want to do that stuff in Java, it is messy. It is painful. I don't even know where to start now. I mean, threads are basically a dead end. They deprecated so many, basically, if you look at threads, it was like, nope, this was a total mistake. Java threads.
They're now switching to like a fiber model,
right.
Green thread model,
right? Which is basically a coroutine approach.
Yeah. So I think and what's hard, I think, with all kind of async stuff is that there's an assumption that if you get the right primitives for it, then you can build everything that you might need
using that one model. Well, that's kind of the Go way of thinking.
Right.
It's like we have this one, you have Go routines.
Yeah.
And I mean, if they're going to work, that's going to be great because it's so straightforward. You could teach people Go and have them using Go routines by the end of the week.
Yeah.
And
but then what often happens is that you have some requirement that doesn't fit that foundational model. And then what do?
That's just concurrency in general. It's a collection. It's a basket of strategies to make your program run faster. And what problem you're trying to solve depends on what strategies you should use. Yeah. And you might not get the right one the first time you try it.
Yeah. Yeah. I think I think at least we're at to the point where people feel that the fiber model is the best foundational model that we've found, and that
And it
that
doesn't have
most
this
things can be built on
huge
top of that.
impact. I mean, like that was the thing with the Java threads is, you could have maybe 700 of them before you ran out of memory because everyone had this huge impact on resources. Whereas fibers and coroutines and what are the various different names for them are so lightweight that you could just have relatively massive amounts before you have to start thinking about that kind of thing.
Yeah.
And I think that's really important because it affects how you think about programming. If you go, oh, I can't, I can't use too many threads. I have to be thinking about that. Whereas if you can just go, yep, just if you want a fiber or coroutine or whatever for every object out there, that's fine.
Yeah.
We can deal with that.
Yeah. Yeah.
Like, I mean, if you're creating a game, wouldn't you want to have every element in your game have its own coroutine?
Yeah.
Probably would.
Except for the UI, because then you're single threaded.
Yes. But then you have a different constraint.
Back to that shared mutable state.
Yes. Yeah. You have that constraint. I don't know if there's any way to solve that problem.
Well, Ponylang says that the foundational model for concurrency is actors. And I haven't seen Ponylang catching on much. So I wonder if at some point they'll kind of recognize that maybe that's not the right foundational.
Well, I guess maybe it's not whether it's the right foundational thing. It's just whether it solves every problem.
Right. Yeah.
And, I mean, like, again, Go trying to solve every problem with Go routines. I don't think entirely, but, because they have some other things. But in order to simplify it, they have to say, well, we're going to solve this relatively large subset of problems, but also acknowledge that there are other things that we can't solve with this model. Yeah. I think that's what you always have to do with coroutines. Yeah. I mean, with concurrency.
Yeah. Yeah.
Yeah. So,
yes, I think, in general, coroutines are good. I definitely miss the monadic way of dealing with async stuff when I'm in Kotlin, just because it gets tricky to do like composition and things like retries, and how do I fan out a bunch of stuff and then pull it all back together. But if one thing fails, what do I want to do? Do I want to cancel all the in-flight ones? There's I think you're saying, the coroutines model is good for a lot of use cases, but then there's a point of complexity where you need something more powerful, and that's where the monadic stuff for me has made a big difference.
Hasn't somebody I thought I had come across one or two people working on some kind of monad library for Kotlin.
Yes. So Arrow is the functional programming library for Kotlin, and it's great. And it adds a lot of the stuff that I have been doing in Scala into Kotlin. So yeah, I think that you definitely can get a lot of that in Kotlin with Arrow. So it just is, if we're talking about coroutines specifically, that's where I find lackings, but you can certainly add that in with Arrow.
Are there, I mean, I think I heard that there were some limitations of Kotlin that prevents full easy monads. Is that true? Or is there
well, so they don't have the do notation, like the for comprehension that Scala has for monads. So with Haskell I think they're the ones that created the do notation, and then in Scala it's a for comprehension. But this allows you to deal with monads in a imperative looking way, and it definitely makes the syntax of monads a lot more expressive. Because then you're normally with monads you do dot flat map, dot flat map, dot flat map, dot map, and nest deeper and deeper and deeper. Whereas with like the do notation, it just looks like an imperative statement, but then it's doing that flat map underneath the covers.
You might have to show me that offline, because there may be a way to solve that.
So I think that Arrow did come up with some like compiler plugin for Kotlin that does give you some of that syntax niceness dealing with monads in Arrow. I looked at it a long time ago and can't remember exactly how that all worked. But
at some point, we may need to do a session on introducing monad, to attempt once again to introduce monads, if we can.
The Monad Podcast.
Yeah. Exactly.
Yeah.
Because there's, we're already using the M word and have not introduced the idea.
I know. It's hard. I can't avoid saying the M word.
It's so integral to your view of the world now.
It is. It is my view of the world. It's all monads.
And I'm
monads all the way down.
I'm slowly getting there. I mean, I'm just chipping away at it, but I'm not there yet. Yeah. So, which would make it a good podcast, because I'm the ignorant one who would be saying, "Wait, what? How do you explain that?" So,
another piece of Scala that I miss when I'm in Kotlin is type classes, and I've found, for me, like, a lot of the programs I use are doing serialization, and serialization is just a great place to apply type classes, because you need something that knows how to take a thing and turn it into, let's say, JSON. You need these, like,
and you can't just use a pattern match
of converters. You can, but where it gets tricky is so.
Or the chain of responsibility pattern. Maybe that's what type classes do for you.
Yeah, I don't explain the chain of responsibility.
Well, it's basically, there's a whole bunch. The way I describe it is, it's a list of strategies, and you just go down the list trying things until you find one that works.
Oh yeah. What's hard is that in Kotlin you have to explicitly create the chain. Mm-hmm. Whereas with type classes, languages with type classes,
the compiler does the match.
The compiler finds the thing that it needs, and so you don't have to explicitly create the chain. And what Kotlin
and it's not
does,
treating it as a chain. It's just saying there's these things out here, and I'll find one that matches.
Right.
Right.
Well, and you have to import. It has to be in an import.
Well, yeah, it has to be in your namespace.
Right, exactly. So you have to tell the compiler, like, where to go looking,
what the possibilities are. Yeah.
But So in Kotlin, a lot of the serialization stuff that I've seen is still using reflection, because that is the way in Java to find the chain of responsibility dynamically. And so, but I prefer the explicitness of type classes to say, here is the chain. But not have to actually pass it and construct it explicitly. So I miss type classes, but I think they could add them to the language.
Yeah, that was going to be my next question.
Rust has them.
Is there any constraint that would prevent type classes from being added?
I think what Scala did was they used implicit, which gets used like 5 different ways.
Yeah.
And so the implicit becomes this really complicated thing. But in Scala 3, they've actually taken the role of implicit and broken it out into the different places where implicits get used, the different...
and they give it different keywords or something?
Yeah, different syntax for the different...
that was going to be my suggestion, is stop overloading a keyword to use for different things. It confusing.
There is a universal idea to it, as far as I understand, to implicit in the different ways that it's used in Scala. Like, it wasn't just arbitrarily picking the keyword, but it was a concept that I never fully understood. Whereas I think Kotlin, now having seen what Rust and Scala 3 are doing, I think they could add something like almost specifically for type classes, which is what Scala 3 did. Is they have now like real support for type classes. And so you don't do type classes through implicits. You actually just do type classes.
Is there a keyword for it or something?
I don't remember, but yeah, there is specific syntax.
There's something. So when you're looking at it, you're not like saying, "Oh, implicit. I wonder if they're using it for type classes here." It's just like, no, that's what it is.
Exactly. There is specific syntax for type classes, and Rust is the same way, as far as I can tell.
Nice.
Well, that's it for today. Thanks for listening.